Okay, so for trapezoids, definition of a trapezoid is a quadrilateral with exactly one set of parallel sides. So we have exactly one pair of parallel sides. Now we're going to call this thing in between. Well, first of all, let's mark our parallel sides. We know that this side, they are the bases. Doesn't matter how they're turned. It could be turned this way. The bases are considered to be those things, those two things that are parallel. So this would be base 1. This would be base 2. Or you could say, sometimes you'll see it written as B1, B sub 1, B sub 2. Base 1, base 2. Or base 1, base 2. It doesn't matter. The parallel sides, the bases are the parallel sides. Now, this guy in the middle is called the median. Now, what do you think the median, how do you think I can draw it? Could I draw the median up here? What is a median? What do you think? Are you just stretching? It does. It bisects the non-parallel sides. So we would know that this is congruent to this, and this is congruent to that. So the median is going to be midpoint to midpoint on non-parallel sides. We have a nice little formula here. The median is 1/2 the base 1 plus the base 2. Now, you may have seen that formula before, or something like it. To find the area of a trapezoid, the area of a trapezoid is 1/2 the height times base 1 plus base 2. See the difference? Height is the difference. Base 1 and base 2 are just the lengths. Now, isosceles. Well, what do we think about isosceles? Kind of like a triangle, but what do we know about an isosceles triangle? Two sides are the same. So the same thing with an isosceles trapezoid. It's a trapezoid with one set of congruent sides. Those sides are called legs, just like in the triangle. Now, could you have two sets of congruent sides in a trapezoid?
No, it's not a trapezoid.
Why would it be a trapezoid?
Because then both sides are parallel.
And they're going to have to be parallel. So we're only going to have one set. So we're going to put in here exactly one pair of parallel and congruent sides. The median is still the same, 1/2 base 1 plus base 2. Legs are congruent. So let's look at this. We've got this guy is going to be parallel to this guy. We have this is congruent to this. And here's our base 1. Here's our base 2. diagonals are what? So, would it be possible for us to prove these diagonals are the same? Let's talk through it rather than prove it.
Did you say it would or wouldn't?
Would it? So, is it possible for me to show this triangle congruent to this one? In an isosceles, not just a regular, but in an isosceles.
Yes.
Okay, give me one thing you got.
Base angles.
How do you get base angles?
Because it's an isosceles trapezoid.
Well,
One angle is congruent to the other.
okay.
There's an
How do we
isosceles triangle in the middle of it.
do we know that though? I would say we've got side. You know this is parallel, so what else do we have?
Alternate interior.
Alternate interior. So I would get this guy and that guy, right? No. That guy and, yeah. 'Cause there is your diagonal. I guess you get that guy and that guy.
Reflexive.
We got reflexive over the base. So we'll have to have our base angles in there. I was hoping we could prove it, but we're going to need those. So base angles are congruent. So then you would have side, angle, side. So the diagonals are congruent. That only works for isosceles trapezoid. You do not have, now these are considered base angles, and these are considered base angles. So we have two sets of base angles.
Does it matter which one is the base?
There's two bases.
Base one.
No,
and base two.
You good with trapezoid? Alright, let's do kite. We're going to have to throw kite on the back. I don't know how kite got skipped. So a kite is a quadrilateral with two sets of consecutive sides congruent. So if we have two sets of consecutive sides congruent, what's consecutive mean? Next to each other. So we would know that this guy is congruent to this guy. And this guy is congruent to this guy. Now, that being said, what do we know about diagonals? Well, first of all, let's look at the two triangles that way. Can we show that those two triangles are congruent?
Yes.
Can we show those two are congruent? Well, we got a side and a side. We got an angle, or a side and a side. We have reflexive. So if those two triangles are congruent, what do you know?
The opposite.
This angle would be congruent to this angle. What do you notice about this long diagonal? What's it going to do to those two? It's going to bisect that angle. Now, could I split the kite the other way?
No.
could I prove that this triangle is congruent to that triangle?
No.
So if that's not the case, do you know this angle is congruent to this one?
No.
No. This guy could be very, very thin, depending on how long I draw this out, and this guy could be very large, depending on how short it is. So we only have one set of congruent angles. One set of congruent, let's put opposite angles. Now, is it possible for me to show anything about the triangles being, or these two triangles? Could I prove these two little guys congruent? Well, what do we know? We know this side is congruent to that one, right? We've got reflexive. So we have a side and a side. You got an angle? Yeah, this guy bisects that angle. So we have an angle now. So are those two the same?
Yes.
Then what do you know about the diagonals? These two are the same. They're perpendicular. So diagonals of a kite have to be perpendicular. So what quadrilaterals do we have perpendicular diagonals? Square. So perpendicular diagonals come from a square. What else?
Rectangle?
Rectangle. Can we show?
No.
Can we show those two triangles right next to one another the same? No. What about a parallelogram? Can you show the two triangles right next to one another to be the same? No. What else we got? Rhombus. Can you show the two triangles next to one another to be the same?
Yes.
'Cause really what it comes down to is, are the two sides right next to each other the same? Rectangle? No. Parallelogram? No. Rhombus? Yes, they're all the same. So that one works. Questions on kites?